Bismillahirrahmanirrahim. Today I'm going to start my lecture on applications of ionic liquid. As you have an idea in my last lecture on the same topic where I have given you an overview about the ionic liquids, what they are, what is the chemistry, how they are produced, and I've given you an overview about their applications. Today I'm going to give a bit detailed, relatively detailed, not in that detailed because it's not a part of in your subject at the moment, but I'm just trying to give you a glimpse into the applications use of ionic liquids so that you can understand their efficacy, their effective usage. So what the ionic liquids were, on that day I've told you they are supposed to be some sort of liquids. They are liquids at room temperature. Liquids at room temperature, and these liquids are supposed to be ionic in nature. So ionic liquids are supposed to be ionic in nature, but they are supposed to be liquid at room temperature. I give you few very simple examples like sodium chloride, sodium hydroxides and other salts which are supposed to be ionic in nature, but at the room temperature they are supposed to be the solids. They are not the liquids, they are the solids. However, in case of liquids, they will be ionic in nature. However, physical presence will be in the form of liquid. That's their advantage, that's their property, that's their beauty that differentiate them from the other ionic compounds, which are generally supposed to be the solids one. Secondly, I've told you the nature of cations or anions affects the properties of ionic liquids. As we have an idea, in case of ionic compounds, one is supposed to be the cation, the other is supposed to be an anions. So the combination of the two generates ionic compounds. What is the nature of the cation? What is the nature of the anion? That determines the property of the resultant ionic compound, especially in case of ionic liquids. We told you on that day, as the simple ionic compounds, cations and anions generate a compound. Similarly, in case of ionic liquid, we are supposed to have some sort of cations, and then we are supposed to have some sort of anions. As a whole, this generates an ionic liquid, similar to the one. It's an ionic liquid, one is cation, the other one is anion. And the same way, I've also explained that those cations in ionic liquids, they could be organic, generally they are supposed to be organic. In case of organic, we told you they could be generated from pyridine, so they could be pyridinium based, or they could be some sort of a pyrrolidine based, having any sort of substituents around. They could be sort of an ammonium based. We have an idea ammoniums where nitrogen is supposed to be substituted with 4 different substituent alkyl groups, They could be phosphonium base having different substituents around as well. So this is how they are supposed to be. The cationic part is supposed to be, the cationic part in an ionic liquid. Similarly, the anions in ionic liquids, as I've just explained, let's say it's a part of an ionic liquid. So we have an anion over here. It's a cation, we need an anion here as well. So anions in ionic liquids, yes, they could be like I've just given you, they could be organics, they could be inorganics. Inorganics, chloride, bromide, fluoride, halides could serve you well in this regard. They could be something like that. An ionic, they could be BF4, PF6, few of the frequently used anions, Then in case of organics, the ones which are organics, the ones which are organic in nature, anions in, so like the organic anions could be alkyl sulfonates, they could be something like that, or they could be tosylates. So few of the common examples of cations and anions which could be put together to generate ionic liquids. So this is how the ionic liquids are produced by the combination of different anions and cations. The speciality of the ionic liquid also that they are thermally as well as electrochemically stable, They are thermally stable. They are electrochemically stable, They are electrochemically stable as well. Thermally stable mean I've told you in the previous lecture, they can withstand temperature up to 400 degrees C. They are stable from 300 to 400 degree centigrade depending upon the nature of the cations and anions, because the nature and the chemistry of the cation anions do control the properties, the physiochemical properties of the ionic liquid. Similarly, they are electrochemically stable, as we have an idea. They are electrochemically stable, the charges are stable. So that's why they have a pretty prominent properties which are different from the common solvents, which are organic molecules, organic solvents, and they're also different from the ionic compounds, So this is all about just the basics about the introduction of the ionic liquid, just to give you a recall, just to give you a recap of the previous lecture. Ionic liquid, due to their immense properties, have widely been used in different areas, as we discussed in last time. They have been used as solvents, they have been applied as solvents in synthesis, They have been used as solvents for extraction. They have been used as solvents for extraction, you know. They have been used for energy applications. Energy applications where they are being used in fuel cells. They are used in capacitors. They are used in lithium-ion batteries. Another domain of their application was as functional molecules, functional materials, you know, that is more appropriate to write here. They have been used in functional materials. Functional materials, they have been used for the preparation of polymers, conducting materials. You know, ionic liquids have positive and negative charges. Positive and negative charges, so they can act as the conducting materials. They can conduct electricity. They can pass on electrons. They are a good conductors. They can be a part of the conducting materials. They can be used for the preparation of conducting materials, in fact. They have been used for the preparation of finishes and many other functional compounds, functional materials are being prepared, synthesized involving the ionic liquids, you know. So these are the main domains, main fields where ionic liquids are showing their beneficial presence, showing their application, you know. And they are replacing the conventional use of the organic solvents, organic materials, and they are advantageously preferred over the conventional ones. One thing came into my mind as well. They are also being used in the preparation of LEDs, you know. LEDs, they are being used in high energy materials, So these are few of the main domains where they have been applied and where they are being used. With the passage of time, they are there to replace the conventional solvents, conventional energy appliances, the conventional materials, you know, with their unprecedented properties. Now let me give you a few examples of their applications in organic synthesis. Applications of ionic liquids in organic synthesis. They have widely been used in almost all types of organic reaction. Used in almost all type of organic reactions. Used in, how they are used? They are being used as solvent media. In fact, they are used as solvents, or you may say that as reaction media. Mean almost all types of reactions could be done using ionic liquids as reaction media. I've seen few reactions like hydrogenation, a frequently done reaction. Hydrogenation reaction is done in the presence of using ionic liquids, to get corresponding products. Hydrogenation has been used using hydrogenation has been performed actually applying ionic liquid as reaction media. Similarly, the other reactions few other examples do involve their use as well, where hydrogenation has been performed using ionic liquids as reaction media. One of the examples where this sort of a compound has been used sort of a carboxylic acid entity having an amine functionality. This has been reduced, this has been hydrogenated using hydrogenation in the presence of an ionic liquids. IL denotes ionic liquid, it stands for ionic liquids, to corresponding product was received so hydrogenation has happened at this bond, so we have received an alkane, a single bond over here. What has happened additionally, the hydrogenation has been performed stereoselectively, a stereoisomer has been generated over here. So ionic liquids do help in the hydrogenation of compounds with stereoselective considerations as well. Another example which has been cited in the literature, where also a relevant compound has been used, this sort of the compound has been used. I'm sorry, it's a double bond here, an alkene moiety, alkene functionality is there next to the carboxylic acid functionality. It has been made to undergo hydrogenation in the presence of ionic liquids as reaction media, and the corresponding product has been received again a single bond has been formed over here, and that single bond means an hydrogen has been added, but the addition of hydrogen has happened in stereoselective way because there was no stereoisomerism over here. The product which we have received after the hydrogenation carries a stereocenter over here. You can see, one can imagine the dotted lines, they represent the formation of a stereocenter here. Is that fine? So hydrogenation has happened at the molecule, and the presence of ionic liquid has made this reaction stereoselective. Stereoselective hydrogenation has happened. So I've given you 2-3 different examples of which do involve the hydrogenation, because hydrogenation is one of the major reactions that is done in organic chemistry. Similarly, another example, I'm trying to give you some brief examples, some uh, it's a sort of a compound where again a carboxylic acid having an alkene moiety, it also underwent hydrogenation. Hydrogenation means addition of hydrogen over here at this bond, which then resulted in the formation of after the addition this carbon, the attached methyl has generated a stereoisomer, mean it has got rotated, it has got rotation in the around the carbon, resulting in the formation of stereocenter over here. So hydrogenation is performed in the presence of ionic liquid, and these ionic liquid actually do help the addition of hydrogens stereoselectively. They produce stereoisomers from non-stereo compounds. Okay, so this is one of the speciality of the ionic liquids. In few of the examples which I've discussed, I've taken those from the literature. You can quote them as such. Then there are some examples where oxidations have been performed, by using ionic liquids as hydrogenation. People have performed oxidations as well. We have an idea. Oxidations are also one of the main reaction category that is frequently performed in organic chemistry. So oxidations could also be done using ionic liquid as reaction media. One of the examples that I'm trying to give you as a brief one do include something, the oxidation of alkenes into corresponding alcohols. Alcohols has been produced from alkenes as a result of oxidations. So this is also one of the simple example, which suggests that ionic liquids could be used for hydrogenations as well as they could be used for oxidations as well. So this is one of the example which gives you an idea about the usage of the ionic liquids in this perspective as well. You have an idea. Few days ago we have discussed Diels-Alder reactions. I've given you a very detailed lecture, Diels-Alder reactions, where we are supposed to have one diene. It's a diene, and it is supposed to react with some sort of monoene, and those reactions do go a sort of pericyclic bond rotations, bond movements results in the formation of cyclic products. I've given you a detailed lecture on it. So this sort of product is expected to be these reactions. Such reactions means Diels-Alder reactions could also be performed using ionic liquids. Why ionic liquids also favors Diels-Alder reactions? Because ionic liquids do carry positive and negative charges, And in such reactions where these elder reactions are, they also involve the movement of electron. The presence of positive and negative charges in ionic liquids favors the movement of electrons from one bond to the other, from one side to the other. So this favorable situation enhances the reactivity of the reactants in these elder reactions once you use ionic liquid instead of conventional liquids, So these elder reactions, they do involve the use of they do involve the use of ionic liquids as well. Similarly, the nucleophilic substitution reactions. The nucleophilic substitution reactions, they could also be used, they are also being run using ionic liquids. You do have the idea why they use ionic liquids, Let's say we have a sort of a naphtha here and we reacted with some sort of ethyl bromide. I can write nucleophilic substitution reactions. This negative entity, the generation of negative charge on naphthol in the presence of an ionic liquid. This negative charge attacks at the nucleophile present in the alkyl halide, kicking this bromo out and giving us the corresponding product. We will have this sort of compounds. So what has happened? This O negative nucleophile has expelled bromo out from the alkyl halide. You do have an idea. It's a pretty simple example of nucleophilic substitution reaction. So what I have given you 2-3 different examples, trying to give you simpler examples once, trying to convince that ionic liquids do favor hydrogenations, ionic liquids do favor oxidations, ionic liquids do favor the these elder reactions. The ionic liquids do favor the nucleophilic substitution reactions as well. This is one of the examples. Few other examples could be like if you have a benzyl chloride and you react it with KCN, potassium cyanide, they do undergo nucleophilic substitution reactions, giving us this product where cyanide has replaced this chloro. This cyanide has replaced this chloro. The chloride has been kicked out. So you do have a cyano-substituted cyano-carrying product, organic compound. So this is another example of nucleophilic substitution reaction. So ionic liquids, why they do favor nucleophilic substitution reactions? We have an idea in case of nucleophilic substitution reactions, the nucleophiles are supposed to carry negatives and the rest of the entity should carry positive charges. So means there are negative positive charges are involved in nucleophilic substitution reactions. Negatives and positives are involved over here. These negative and positive charge generation, that is facilitated by the presence of ionic liquids because they do carry negative and positives as well. So where there is a negative and positive charge is present in the solvent, such solvents favors the nucleophilic are electrophilic reactions because they can generate positive and negative charge on the molecules as well, because they have the powers, they have the properties to solubilize the opposite charges. So that is why the ionic liquids do favor the nucleophilic substitution reactions. These are the one or two simple reactions for your kind attention, please. So what I'm trying to convey you, many other reactions are possible. So ionic liquids are being used in organic synthesis, in organic reactions, in more than many organic transformations. They are being used in hydrogenations, they are being used in oxidation reactions, they are being used in electrophilic substitution reactions, they are being used in nucleophilic substitution reactions. Electrophilic substitution reactions are the Friedel-Crafts reactions, the nitration of benzene, the sulfonation of benzene, the acylation, the nitration, all those reactions could be run using ionic liquids. If you just Google the applications of ionic liquid in electrophilic reactions, or you may write the reactions of benzenes in ionic liquids, you will get those. Friedel-Crafts reactions of benzenes are very much known in ionic liquids. So ionic liquids are capable of favoring electrophilic substitution, nucleophilic substitutions. They are capable of favoring oxidations. They are capable of favoring reductions, hydrogenations. They are capable of favoring. They are capable of facilitating even Diels-Alder reaction. They are capable of favoring nucleophilic additions. Nucleophilic addition. Let me give you one example. In that very respect, I've seen in the literature the aldehydes, ketones, the aldehydes and ketones, they do undergo nucleophilic additions in the presence of ionic liquid. From this entity, the hydride H negative is generated, is separate out H negative, which attacks over here and giving us the corresponding alcohols. They give us corresponding alcohols. This negative is balanced by one of the proton which will come from the acid. You try to recall the reactions of aldehydes and ketones with nucleophiles, where nucleophile used to attack at this carbonyl carbon, and resultantly there is supposed to be a negative charge which is then balanced by one of the proton from the acids. So the ionic liquids are also capable of facilitating the nucleophilic additions, and nucleophilic additions happens in case of aldehydes and ketones. I've given you a very comprehensive lectures on that as well. So what is the conclusion? Ionic liquid are important class of solvents. They do favor almost all types of chemical transformation. They could be hydrogenations, they could be oxidation, they could be nucleophilic substitution, they could be electrophilic substitution, or they could be nucleophilic additions. So this is the prime examples that ionic liquids are progressing towards the organic synthesis due to their advantageous applications as solvents, because they can withstand different charges, molecule, they can solubilize them, they can favor the generation of positive and negatives on the molecules. So they favor the nucleophilic and electrophilic generations and nucleophilic electrophilic reactions as well. So the ionic liquids are preferred over the conventional liquids due to their solubility, due to their thermal stability. Let's say if you are going to run any addition or a substitution reaction that requires temperature above 100 degree, and the reaction requires the time as well that is beyond 12 hours, like 18 or 24 hours. The conventional organic solvents like methanol, any other solvent, they will be in a danger of evaporation or decomposition if you are running reaction above 100 degree for a longer period of time. However, if you use ionic liquids there, you have an idea they don't decompose even till 400 degree, and they don't boil as well. They have a low vapor pressure, mean they don't boil at ordinary temperatures. So they will favor your reaction pretty well even at higher temperatures. That's why the organic chemists, the synthetic chemists do like to use ionic liquids in place of uh, conventional liquids, conventional solvents. However, in this very perspective, there's a big hurdle, at the moment. That's why the ionic liquids are not that frequently used in ordinary labs because they are a bit expensive. The economical issues there, which has to be settled down. If they are available on economical prices, then surely they are going to change the chemistry. They are going to change the synthetic perspective, in organic chemistry. I hope you got the idea. You got the basics about the ionic liquids. You got the basics about their application. If you have any question, please don't hesitate to ask. You can put your comments, your question in comment area, or you may approach me via WhatsApp. I will be happy to answer your questions. Thank you very much. Assalamu alaikum.